So go through, what I would advise you is go through that, Brendan, go through this, it has many examples. So go through this, like the one that I've sent you. Try the questions because they have got answers, most of them. Try the questions, they have answers, I think so. Most of them have got answers. Clear. Then try to use the formula. So it's just for you to go through. I'm not going to look at that because we have almost finished everything. Clear.
Yes, sir.
Okay. So this chapter, actually, we have finished this chapter. We'll look at questions, but there's something that I want you to go through so that we combine with this chapter. There's some chemistry that you need to know. Some chemistry. So we're going to look at periodicity. Then we'll combine with this topic. It will make sense. Then after that, we'll have a nice chemistry test. Periodicity. Do you all have periodic tables close to you? You need periodic tables when you're dealing with periodicity. Can you make sure that you've got your periodic table? You open your periodic table. Then we learn periodicity. Then I'll tell you the tricks. Then I'll tell you the tricks. Clear. Things that you need to master so that you don't struggle in chemistry. Because last year I had many students now asking me, say, how do I write this equation when they're about to write an exam? It shows you that there are things that they didn't master. Periodicity, clear. Once you master this, it will be easy for you to remember. So now, let's talk of certain things from a periodic table. Everyone, this is a very important topic. So, yeah, it's 1 hour. So now we need to talk about properties of a group. What is a group in a periodic table? If you're looking at that periodic table, when you're saying a group, what are we talking about? I think in a periodic table, you've got something like this. I'm not going to draw it, then something like this. Then you have a gap like this in between where you've got that. Is that correct? Then you've got something like that, group 3 here, then group 4, group 5, group 6, group 7, up to group 8. So when you're talking of groups are the ones that are going down like this. Clear? Those are what we call what? Groups. Going down everyone, we call those groups. So the first one there is group 1, going down. The second one is what? Is group 2. Then we skip this. Then this is called the D block, transition metals. Then I've got group 3 metals. So group 1 metals, group 2 metals, group 3 metals. Okay. So the first thing that I'm going to tell you, or that we need to write, is that group 1, you can write that down. You need to know that so that it's easy for you. So group 1 to group 1 to group 3, all metals. Clear? All metals. Group 1 to group 3, all metals. Clear?
Yes.
Now, group 4. Group 4 are what we call what? Group 4, who knows the name? It's called metalloids. Because it is a mixture of metals and non-metals. As you go down the group, it becomes metallic. Clear? As you go down the group, it becomes metallic. Are you together? Down the group, you've got metals. So it becomes metallic. Okay. Metalloids, because they behave as metals, they've got this behavior of metals and non-metals. Now group 5, non-metals. Clear? Group 6. Can someone tell me what do you have in group 5? Looking at your period table, I want to see if people are looking at the correct period table. Can you tell me any element in group 5?
Nitrogen.
Nitrogen.
Nitrogen, correct.
Phosphorus.
Yes, correct. So you are looking at the correct group. Now group 6, non-metals. Group 7, non-metals. Clear? Group 7,
Yes.
non-metals. Then group 8, also non-metals. But these ones are called, they are innate noble gases. Very stable, they don't react. Clear? We'll talk about that
Yes.
now. So now what I said is I want to so chemistry, if you need to be good in chemistry, you need to, you can write that NB, you need to know the reactions. You need to know the first 20 elements in detail. We need to know the first 20 elements in detail. If you want to be good in chemistry, all level chemistry. First 20 elements in detail. From hydrogen, I'm saying from, you're looking at those proton numbers, from hydrogen up to calcium. We need to know those first 20 elements in what? In detail. In terms of their nature, their reactions, clear? Which is not difficult. Now let's start with group 1. Let's start with group 1 and talk about group 1 just now, in brief. Group 1. Number 1. We said they are all metals they are all solids at room temperature. Group 1s, all metals. Always remember that. Group 1, all metals. Clear? But unlike other metals, which is a key term here, unlike other metals, they have, what do they have? Low boiling points and melting points. We are comparing with other metals, and melting points. Clear?
Yes, sir.
So,
So they have boiling points and boiling points and melting points below 1,000. All the other metals are above 1,000. Now, then they are soft. Unlike other metals, they are also soft. They're the only metals that are soft metals. All the other metals are hard. Soft metals. You can cut them with a table knife. And cut with a table knife. Clear? Are we together?
Yes, sir.
Then they are the most reactive. They are the most reactive metals. They are the most reactive metals. So if they are the most reactive metals, how do you keep them in a lab? If they are the most reactive metals, how can you keep them in a lab? It means if you simply expose them, they start reacting with air immediately. How do we keep them in a lab? Who knows how we keep them in a lab? Kept in a glass jar with oil on top. Why oil on top? Why are we putting oil? Oil
to prevent air from entering.
prevents them from reacting with oxygen.
Oxygen.
Oil is a seal that prevents them from reacting with what? With oxygen. Clear? Most reactive metals, we keep them in a glass jar with oil on top to prevent them from reacting. Because oxygen, oil provides a seal, so it prevents them from reacting with oxygen. Clear? We want to preserve them and use them for many experiments. Are we together? Making sense?
Yes, sir.
Or not making sense? Making sense, huh? Then we can do what is called a flame test for group 1 metals. Huh? Flame test. We're still dealing with group 1. You need to know all this in detail. So with lithium, if I burn lithium, what color do I expect? Potassium. So you only need to know the first 3. The rest you don't need to know in detail. Yes, what color do you get? A. Sodium, yellow flame. Lithium, what flame do you get? Potassium, lilac. What did you say? Oh, purple. This one, I think it's crimson. Red flame, huh? Clear. You can check on Google, you see that. Those are the flame tests that you carry. Now we're just talking of so the other property. So I'm talking of the physical things. Huh? So we said they've got low boiling point. They also have low densities. Huh? Low group, they've got low density. Low density or group 1 metals. Then you can write that the first three metals, which is what? Lithium, sodium, and potassium have a density less than water. What is the density of water? 1. Huh? Have a density less than water. Have a density less than water. Why is the density of water 1? From form 1 and 2 or primary, why is the density of water 1? So it means they what? They float. Huh? As they react, they float in water. Now, why is the density of water 1? What is density? Density is mass over volume. If I have 1 kg of water, if I can put it that way, if I have 1 kg of water, if I have 100 grams of water, which is 1 kg of water, it gives you what? The volume of water is exactly 1,000 what? Cubic centimeters. Huh? Clear? I thought you knew that. That's why water has got a density of what? Of 1. Yeah? Clear? So they've got low densities compared to other metals. Other metals are heavy. Clear?
Yes.
Now, so these physical properties are important, huh? But now what's more important is the chemistry, the chemical properties. So now let's look at the chemical properties of group 1 metals. Chemical properties. Then we'll talk about the reactions and what you need to remember. Chemical properties. Now, in terms of chemical properties, your group 1 metals, number 1. Group 1 metals have what? A valency of 1. Valency of 1. What is valence? What is valence? Kuda, what is valence?
The highest number of electrons in the pure cell.
Valency is simply the number of electrons in the last shell. In chemistry, when you're saying valency, is the number of electrons in the last shell. Last shell. Let's do something quickly. Don't write it in your notebook. I think you have, if you check your periodic table, you have lithium 7,3. Confirm, is that correct? Like this. Then you've got sodium, just confirm, 2311. Is that correct? Or is the other way? It doesn't matter. What do you have, in your books there? That huh? Is it exactly like this or the other way around? Period tables that
Sodium it's the left.
Other way.
huh? It's the other way.
Yeah.
Makes sense.
Okay, it's fine. Maybe you have something like this. Doesn't matter. Like this. So what I'm saying is, in an exam, you should never be confused by this. Huh? You can have 11 here, 23. Doesn't matter. Then you have potassium. So there's one way to do this. There's another way to do that. They like doing this, twisting this in the exam. What you always need to remember is that the mass is always greater than the proton number. So it means the mass here, this is the mass, this is the mass, this is the mass. This is the number of protons, which is equal to the number of electrons. Huh? So it means lithium has got, before it reacts, it has got 3 what? 3 protons or 3 electrons. So how do you do configuration? First shell always occupies 2 what? Electrons. You are left with what? With 1. Clear? Let's go to sodium. Sodium has got 11 electrons. First shell always occupies 1. Second shell maximum of 8. Last third shell maximum of 8. 281. Can you see that? Let's go to this one. So it is 2 shells, 3 shells. Now this one, 2, 8, 8, 1. Clear. So what's the valency? 1. What's the valency? 1. What's the valency? 1. So that's why I said the first chemical property, group 1 have got a valency of 1. All group 1 atoms, they have 1 electron in the last shell. All group 1 elements have got 1 electron in the last what? Shell. Is that making sense now, everyone?
Yes, sir.
From what I've written here, what happens is we are going down. Was from lithium we are going down. What's increasing here?
The number of shells.
How many shells here? 2 shells, 3 shells. So you can write the next property. The number of shells increase as we go down the group. The number of shells increase as we go down the number of shells increase as we go down. The number of shells increase as we go down the group. Clear? Number of shells. Then what did we say about the reactivity? Now the third property is that the reactivity increase as you go down the group. The reactivity, we need to explain it just now. Increase as we go down the group. Reactivity increase as we go down the what? The group. Reactivity increase as we go down the group. What's the reason why it increases? What's the reason? Now, if I pick lithium here, it only has got, so every nucleus is positive. Huh? Then it has first shell, we said 2, 1, huh? And there's only 2 shells like this. Huh? So this is, okay, if I was to do this, and 1 here, this is my lithium. If I was to go to sodium here, sodium has got, so it's got your positive nucleus here. Then you've got first shell, which is 2 electrons. Then you have we have got 8 electrons, like this. Electronic configuration can be drawn. Then the last shell, what? 8. So what happens as we go down the group? We move further away. Look at the distance here. We move further away from the what? From the nucleus. Huh? Concentrate with the valence. the valence electron moves further away from the nucleus. Remember, the nucleus is positively charged. The electrons are negatively charged. So there is a force of attraction between the nucleus and the valence electron. So as we move down the group, the distance between the nucleus and the valence becomes further away. So it means the force of attraction between the nucleus and the last shell is now weak, clear. So if it's now weak, it's so easy to remove the electron. Huh? So that's why the reactivity increases, because metals give away electrons, clear. So this lithium is difficult to lose electron than this one. Why? Because this one, the force of attraction, because this is further away from the positively charged nucleus, clear. So that's why as we move down the group, reactivity increases, clear. What do you think happens to the boiling point and the melting point as we move down? If we apply what I'm just saying, what happens to the boiling point and the melting point as we move down the group?
I think it decreases.
Correct. It decreases because you now need less force to break the forces of attraction there. So you can write that boiling points. This is most students confused that. Boiling points for group 1 and melting points decrease as you go down the group. Boiling points and melting points by point decrease. As you go down the group. So by the way, just a caution, boiling and melting points are not chemical properties, they are physical properties, clear? Boiling points, they are all in chemistry, and melting points, they are under physical properties, clear? I was just mentioning because I was saying something that we didn't talk about. Are we together? So reactivity increases as you go down the group. Then in brackets, in a school lab, you are only allowed to keep the first three. Huh? In any school lab, you are only allowed to keep the first three. What are the first three? Lithium, sodium, and potassium. Why are we not allowed the other ones? Lila, why are we not allowed to keep rubidium and caesium? Because it's very dangerous, especially with students. You can form explosive bombs. Huh? That's how very reactive they are. Clear? We can't be trusted to keep them. Huh? Are we together? No school can be trusted to keep
Yes,
those.
sir.
No school can be allowed to keep those. Now, so we're talking of the chemical properties. Now let's look at the chemical reactions under chemical properties. Chemical reactions of group 1. Huh? The whole lesson is on group 1. So that we master group 1 and the reactions. Huh? Chemical equations. What's the next lesson after this?
Computer science.
Oh, that's one.
Thank you.
Nice. 2 hours, I think. Then I think there's physics, actually. Oh, I'm wrong. What's after computer science? What's after computer science?
Geo.
That's one. Oh, there's okay, geo. 7, 2, Nice with them. I had forgotten that. Okay, that's fine. So chemical equations of group 1. I hope you guys are writing this, because sometimes not in the way it will be structured in your books will be different from what we want to look at. But anyway. So now, reactions with water, number 1. So it's not difficult, Karen. You just need to remember the reactions. Reactions with water and how each one reacts. Reactions with water. I'll start from there. Now, what's happening to my pen now? With H2O. Everyone now knows that H2O is what? Is water. Clear? So in general, then we will look at the actual questions. Group 1, metal plus, sorry, I don't know what's happening to my pen, plus H2O, water, will give you metal hydroxide. Metal hydroxide plus hydrogen gas. It's always metal hydroxide plus hydrogen gas for all of them. Metal hydroxide plus hydrogen gas. Clear? Metal hydroxide plus hydrogen gas. Okay. Now let's talk of individual. Let's start with the lithium now. Reaction of lithium with. So maybe before we, so you can write that all react with water, with cold water at room temperature. You can write all group 1 metals react with cold water. You don't need to heat them. All group 1 metals, because they are very reactive, react with cold water at room temperature. All group 1 metals react with cold water at room temperature. Why is my pen no longer writing nicely? Did I do something? Someone was doing something to my pen. Now let's start with the lithium. Clear? So lithium plus, I'm now writing the chemical, which is very important, plus water, we always form lithium hydroxide plus H2O. So if you can go back here, okay, maybe before we complete this, go back here where we said general. So write X here, X is for a group 1 metal, plus water, we always form a hydroxide in this form. Clear? Plus hydrogen gas like this. We always form a hydroxide like this. Then it's not balanced because I have 2 there. So you put 2 there, 2 there. Write that. That's the general for any group 1. When you react with the water, so you balance this for 2x there, 4 hydrogens. So it's not balanced here. We need to put 2 here. So that I've got 4 hydrogens, 2 hydrogens plus 2 of them, 4. 2x, 2x, 2o, 2o there. That's the balance equation, clear? So write that just so that you remember this. This is the balance equation for any group 1 reaction with what? With water. I'm now showing you the tricks now. Clear? So now, this is not balanced. Remember what we said? We put 2 there, and 2 there. So, the nice thing about that, all group 1, whether it's sodium, you're simply replacing lithium with sodium. It will be the same reaction, clear? Because it's from the same group. Are we together? But there is a way that so we need to write notes now. We need to know in terms of chemistry, they might ask you how does sodium, how do the reactions differ, clear? So sodium, you can react now that it reacts steadily with cold water. observation, it reacts steadily. Reacts steadily. With cold water. Cold water. What's the other observation? I want to see who remembers or who has done. If hydrogen is produced, hydrogen is a gas. Huh? Remember, we have dipped our lithium in water. Our lithium, whether it's small, we have dipped it in H2O here. So we have so much water, even as this is formed. So this is actually soluble. We'll talk about that later. So it reacts steadily with cold water. So what will happen to this hydrogen? It tries to escape, huh? Because the hydrogen does not dissolve in water, it escapes. But as it is escaping, what does it form? What do you see? Who knows what you see? You see bubbles. What do you call those bubbles? Karen, a word that you should never forget today. What do you call those bubbles? You observe, and it's called an effervescence, clear in chemistry. So you observe, everyone, an effervescence. Those are the bubbles, huh? As the gas is trying to escape. You know what? You observe an effervescence. The reason hydrogen is produced, huh? Because hydrogen is produced. Clear? You observe an effervescence. Besides observing the reaction, how together? You observe an effervescence. Clear now?
Yes, sir.
Okay. So this one is soluble in water. This one, it's aqueous because it dissolves in water. Now, I'm not sure what's happening to my pen. It's acting funny. What's happening? Now, sodium. Sometimes this is not writing properly. Sodium. What do you think about sodium? How would that react? So sodium, the same equation, let's write it down. Na plus H2O. Just master this, what we said. So the same formula, sodium hydroxide. It's known as sodium hydroxide plus hydrogen gas. Balancing equation 2, 2, 2 there. Clear? Just like what we did before. Huh? Sodium, this is a gas. Sodium hydroxide. Clear? Everyone, sodium hydroxide. Now, the question that you want to ask me is how does it react? Rapidly. Clear? It reacts rapidly with cold water. Cold water. So what do we do in a lab? This is a big lump or a small one? A small lump, huh? Or you can use a grain of what? Size of a grain of rice, huh? Clear? In a water bath. We prevent using a test tube because it can break. Huh? That's how explosive it can be, huh? In a water bath. Clear? Now, if you use a big one, you can actually break the test tube. Clear? Because there's so much heat that is given off. Then you also observe a yellow flame. You observe a yellow flame. Clear? As it is reacting. Then obviously you observe an effervescence. We explained the same thing, huh? Because effervescence. Observe an effervescence. So obviously you see more bubbles, huh, than the other one because it's more reactive. Clear? So my question is, if sodium, hold on, if sodium reacts rapidly, what can you say about potassium?
I think he reacts vigorously.
Vigorously. Vigorously. Yes, that's correct. If vigorously is or we can say it explodes in water. Let me just, okay, hold on. Okay, before we continue these equations that I'm giving you here, why are we not mentioning the colors of this? So can you explain to me why are we not mentioning the colors of the hydroxides? What's the reason? Because group 1 hydroxides dissolve. Remember, it's in water. They completely dissolve in water, so it will be colorless. You want to see that, yeah? In terms of observations, clear. That's why we are not mentioning that. Now, the last one, so you don't need to know about rubidium, potassium. So the same equation, K plus H2O forming potassium hydroxide. So the more you remember these equations, practice, the better in chemistry. So 2 there, so that then you put 2 there, you've got 4 hydrogens, 2. The same thing, clear. Solid, liquid, aqueous, gas. If you want me to write the state, this is a solid here. This is a liquid. This is in water here, which is colorless. And this is a gas. Clear. Now we said it reacts like what he said, it reacts vigorously. Reacts vigorously in cold water, producing a lalic. What's happening to my pen? Okay, sorry guys. This guy just producing purple flamer. Clear. Make sense? Now, what are the observations? Observations. Observations, Karen. Some of them are the same. What are the observations? We talked about the flamer. You observe, this is one observation. What's the other observation? Effervescence. Why? We are producing that. So effervescence. See the bubbles. Effervescence. Clear. Observation. The other observation which I left out is that there will be a temperature increase, because the reactions are very exothermic. Temperature increase. If you are measuring temperature increase. It's clear. If you touch the bigger whatever if you're using it, drinking a beaker, it will be very hot. Clear. Temperature increase. Very exothermic. Clear. Making sense or not making sense? So that's group one with water. Kind of. You simply need to remember what I said. The general equation, how lithium reacts, how sodium reacts, how potassium reacts. Effervescence, I explained it, because hydrogen gas is produced. You remember you are putting your sodium, which is a solid. You are adding that in water, and you are leaving the reaction to take place because they have got so much water. So when hydrogen gas is produced, the gas does not dissolve in water; it's trying to escape. As it is escaping, it forms bubbles, and those bubbles are what we call effervescence. So it's an observation because you observe effervescence. You observe a purple color, purple flame, because we're talking of potassium. Then you also observe a temperature increase if you're measuring what? If you are using a thermometer, you're measuring before or during the reaction. There will always be a temperature increase because the reaction is very exothermic. Okay. Chemistry is not difficult. Now, so those are the first reactions, set of reactions that we need to know. The next now is the reaction of group 1 with oxygen. Reaction, you can write that reaction of group 1 with oxygen. Reaction of group 1 with oxygen. I'm looking at the time here. Reaction of group 1 with oxygen. The reactions with oxygen. Pen is not working properly. I'll see why. Reacting with oxygen. Clear? Reactions with oxygen. We are reacting. Now with water, we said we are forming metal hydroxide. If it's lithium hydroxide plus hydrogen. Now if we react with oxygen, we simply form an oxide. So group 1 metal here plus oxygen gas, we form a formula like this. That's all you need to remember. So this is a group 1 metal. X is standing for any group 1 metal. We form this. Clear? And the oxide that we form is a solid. So this is a gas, this is a solid. I'm sure you know that this is a gas. Now what we form here is we can write that down. In general, we form white oxide. White oxides. All group 1 metals are white oxides.
Okay.
Clear? Are white oxides. So what it means is now I can replace the X, look at this, with lithium. That's all I'm trying to reach out to you like this. Then I will simply have lithium 2 or like this. Then if it's sodium, simply sodium plus oxygen, I'm forming sodium. The oxide is always like this, clear. If it's potassium, that's how easy the topic is. It's potassium oxide like this. Are we together? That's how the oxides are like. Group 1 oxides. Clear, clear, clear. Or not clear. But now you need to ask me how is it going to react with oxygen. Now let's look at how so you can summarize. So how do you think lithium reacts with oxygen? How does lithium react with oxygen? Can someone try? I want the how. How does it react with oxygen? You guys are quiet. Remember I said the moment you expose them, they start reacting. So how does lithium react? With oxygen.
Doesn't it like catch fire?
Lithium. How can it catch fire? Look at water. We even said the reaction is we said steady. What about oxygen now? It's a slow reaction. So you can summarize that lithium reacts slowly with oxygen. Lithium reacts slowly with oxygen. Clear? And your sodium? It reacts. What does sodium react? The sodium with oxygen. What does your book say? It reacts steadily with oxygen or with air at room temperature. So you don't need to add the heat for any of them. It reacts steadily with oxygen at room temperature. Then potassium reacts rapidly with oxygen. And they all form white oxides, by the way. Clear? Making sense? Now, homework. So, the last thing that we need to look at is we need to look at, so go and read on a reaction of group 1 metals. Write down, go and read on a reaction of group 1 metals with chlorides, with group 7, sorry, with group 7 halogens. Reactions of group 1 metals with halogens, which is group 7, and decomposition of group 1 carbonates. Two things, reaction of group 1 with halogens. Number 2, decomposition of what? Of carbonates. Then if you have time and data or whatever, what you can try is, since you are in lockdown, maybe you don't have access to experiments or whatever, you can just go and check these reactions. They are there on the internet. You can just Google reactions of group 1 with lab experiments for reaction of group 1 with what? With water. Clear? Then you see some nice clips. Makes sense? That can help you to remember things. Are we together?
Yes, sir.
Karen? Only one person submitted physics, and she did very well. See, physics experiment. The rest, I'm sure, maybe you are working or had forgotten. Finding specific heat capacity. It was only Laura that submitted and showing all her calculations from the video. Karen, are you still watching the video?
The one with the kettle.
Yeah.
The one with the kettle, sir.
Yes.
Yes, sir. I'm unable to do that, sir.
Why?
So our kettle that we have is kind of broken, sir.
Some of you have to confirm with your moms. I don't trust you. And the rest?
You can even ask her, sir.
And the rest? Why were you quiet and not? And the rest you have forgotten. Kuda and friends.
Say, wasn't it due today?
Yes, due today. But I'm just asking. Okay, reminding you also. Due today. Okay, we'll see you for computer science. Those that do computer science. And geo.